Okay, hello and welcome everyone to this this is the 11th National Webinar on Medical Education organized by the Department of Medical Education in Jipper, Puducherry. The topic for today's webinar is Learning Analytics and Artificial Intelligence in Medical Education, delivered by Professor Dr. K. Shantaraman from Tirunelveli Government Medical College, Tamil Nadu. Here is a short background about today's webinar. Many factors influence decision making in medical education. There is a popular saying in educational science which says what gets measured gets managed. In this context, all higher educational institutions, including medical colleges, generate a lot of data about their students and other aspects of their institutions. Only some of these gets documented, and very few are taken for any decision-making process. For instance, though the higher educational institutions generate a lot of data about their students with respect to their learning, practice, and other aspects, when it comes to decision making, only the academic achievement and their attendance is considered predominantly. Data science experts say that we are in the era of big data, and it was reported in 2015 that 90% of the world's data was produced just in the previous 2 years. And this has influenced all fields, including the field of education. Data on students' engagement with the content, student engagement with teacher, student engagement with the learning environment, learning objects, the digital footprints generated by learning management systems, etc., are not documented. And even if documented, they are not considered for educational decision-making processes. All these information, which are called as big data, has many educational implications, and higher education institutions are looking to use this data to improve upon their teaching, learning, and for the all-round development of their learners and for making effective educational decisions. Our speaker for today, Dr. K. Shantaraman, will share his thoughts and experience on the concept of learning analytics and artificial intelligence and their implications in medical education. A brief introduction about our speaker. Professor Dr. K. Shantaraman is currently the Vice Principal and Professor and Head of the Department of Ecology at Tirunelveli Medical College, Tirunelveli, Tamil Nadu. He is also the Coordinator of Laboratory Services, Coordinator for Research, Chief Nodal Officer for Accreditation Processes, and Nodal Officer for Model Rural Health Research Unit, and member of various other committees. He is currently the Chief Editor of Tirunelveli E-Journal of Medical Sciences. He has published research articles in peer-reviewed journals, and he has developed a passion for medical education technologies and is actively involved in faculty development programs for the last 1 decade. I now invite Professor Shantaraman to deliver his speech. Welcome, sir.
Yeah. Thank you, Dr. Jayaprakash Rasman, for your kind and very glamorous introduction. To introduce myself, as far as this topic is, am I audible, please?
Yes, sir, audible, sir.
Yeah.
Go ahead, sir.
As far as this topic is concerned, I think I am as infantile as most educational teachers all over this country. And I would like to start with my presentation by saying one thing is, we are all in the learning curve of a new technological advance, which possibly maybe will be dominating the educational field over the coming decade. So I'll share my slides. I would request all of you to just say whether it's clear to you now.
Yes, sir. Yeah, it's clear, sir. Clear.
Is it clear?
Yeah, clear.
Okay. So today's topic would be on learning analytics and artificial intelligence in medical education. I'm not going into too much of technical details in this talk because it I think it's a very big field which cannot be condensed into a 45-minute lecture. So today's session, we would be just touching on what exactly is data, or data needs, sources, types, what is analytics, and what is the application of learning analytics in medical education, and possibly a mention of what machine learning and artificial intelligence can help in case of medical education. My interest in learning analytics and medical education started off in the year 2015-16 when I started developing research projects based on data analytics. So that's when I started reading. I came across this very interesting publication by Fuzon Go, faculty of the National Institute of Singapore. And that is exactly when I got interested in that point of how exactly learning analytics can help the process of learning, process of administering learning, and process of setting the goals and what you call as the objectives for teaching. So with this, I would like to get into my topic today. These are the set of questions which most of us would have encountered during the process of our walking through the colleges as faculties. So we would have had parents or teachers or public asking us, which is the best medical college in India? How many of your students get university ranks? How many of your students get PG seats after the MBBS course is over? How many first year students get distinctions? Or how many of your final year students know CPR? How many of your CRRAs can place a venous cannula? These are general questions which we have already always faced. So you may ask me, what is this to do with learning analytics? See, these are all the general issues that concern the learners and the people who surround the learning community. So these are questions which the prospective students, the administrators, the government have been continually looking for answers. And of course, benchmarking institutions like the NIRF have a lot of questions regarding these issues, like the number of programs you run, the retention rates, the career of your old students, and of course, what funding you have. So what happens is, every time in our life, during the process of working in a medical college, we look for a lot of data or look for a lot of information. And the world around us, the world around the educational environment also seeks a lot of data from us. Similarly, during the course of learning, what is the data that teachers and learners are looking for? So let us go through a couple of very small scenarios. See, a student A, a pre-final student, walks into the community medicine department, and the professor is quite very upset that this fellow was 10 minutes late for the test. So here, there is one data which was crucially missing for the student. That is, he did not know that there was a test happening. So this information is a single point data. Scenario number 2, there was a person, Mr. B, a second year student, who walks into the pathology professor's room and says that he failed in the recent exam, recent class test. The professor calls in the mentor, and the mentor pulls out a lot of papers which talks about the student's interactions in the class and his performance in the formative assessment and two-way feedback. He has all the records with him. So very interestingly here, the data or the material that the mentor has pulled out has two things. One is the quantitative data, that is the marks the student has scored, the attendance the student has gained during the course. And the other is the qualitative data, which is opinionated data or opinion data rather, where the student's behavior in the class has been commented on or remarked. The mentor has something to state to the professor that the student was sitting in the first bench for the till last 2 months. Slowly he has migrated to the last benches. He is now found to be gossiping in the class and sometimes disturbing the classes too. So the professor now knows that the student has some problem in his mind which needs to be solved. The professor can call in the student for a counseling or probably put him across to a good mentor who can counsel him. So what happens is the solution, the data has created a solution. Now come to the third scenario. A student C walks into the medicine professor room and says that in spite of 2 repeat classes and repeated requests to the concerned faculty, the entire class is not able to understand the process or method of auscultation. This is quite a very very discrete, or not a kind of discrete, but it's a global issue for that entire class. So the professor calls in a faculty meeting to review the class SLOs. So automatically when the faculty is all joined together, the SLOs are pulled out, the notes of lessons are pulled out, There is a discussion on the content delivery, what was the classroom interaction with that particular batch, the classroom assessment done regarding auscultation, the feedback in the formative assessments, what are the campus interactions of this batch. So what happens, there is multiple quantitative and qualitative data sets that are on the front of the professor, with the usual kind of analysis that we as faculty have been doing in all these years. The professor sits confused because he has a lot of quantitative and qualitative data. He doesn't know how to manage the data, or what is the conclusion he needs to derive with the existing data on his table. So the professor needs some more help than the usual kind of assessment that we do as teachers. So now I go to understand what data is. So data is a characteristic or an information. It's possibly a number or a nominal. It may be collected or derived. It may be observed or experimented, may be qualitative or quantitative, or may belong to persons, places, or objects. So this definition is quite very clear. Data is not a specific issue. Data is everywhere. So the data sources would be that data is everywhere, data is too many, data is varied. So whatever you see, for example, some day morning at 6 o'clock, you get up from your bed, to night 11 or 12, you get back to your bed. Whatever you do, whatever you say, whatever you see, whatever you hear, whatever you handle could be data. But what makes it important or unimportant to us is what exactly is the source of the data and what is our need. So again, when I say the word source, you should understand that sources are also as varied and as different in shapes and sizes. For example, if you read your pathology textbook, there is something like 2000 pages of data. You read a couple of pages for that day, that 2 pages becomes your data. You look at the attendance register of your students, the 150 or 250 attendance mark for the day is a data for you to analyze. So automatically, what is the material you are looking at, what is the source you are looking at, also makes the variety far more larger. So now coming to how to exactly understand data. So very interestingly, when Lata Mangeshkar was singing, her voice was clear and loud, and the musical instruments in the background were all subdued and very few in number. Her voice was clear and what she sang was very clear. The voice, the lyrics were all clear, and we could understand, we enjoyed that kind of music. That was in the early 90s or the late 80s. And if you can remember those days, when Lata Mangeshkar was our sweetheart in singing, we used to carry sheets of paper in between our tables, and whatever we thought, whatever we wanted, whatever we had to do with our profession, we wrote letters, wrote notes, everything was on paper. Even when we went to classrooms, we carried a bunch of papers with us for the class. And similarly, when we wanted to talk to our seniors or juniors or peers, we used to sit one-to-one, and across the table talk was there. And if you all senior people can remember, all of us went to our offices carrying a briefcase, which was sometimes very hard, a thick-boned briefcase with a lot of papers, books, etc. inside. And our tables in our offices were all filled with a lot of bound volumes, either textbooks or registers or records, all that. But after the 90s, very interestingly, the computers got into the offices of the teachers and the learners. What happened was, to be very clear and specific, Dr. Chitra started singing, but her voice was not clear because the number of music instruments in the background were slightly cacophonic. Similarly, the way in which we work, the data which we carried were no more in papers. A lot of them started going on to the desktop of the computers into small, what you call as images like this, which we called as folders. We created folders, put all the letters we wrote, the data charts we prepared, all of them into the folders. And if we wanted to communicate with our seniors, we started sending our messages by email or SMS, all that. And the late part, slowly, WhatsApp also picked up. And the briefcases were replaced by small backpacks, which had a laptop sometimes. And many of the papers or whatever documents which we needed to carry got entrapped in small metal pieces. Earlier it was a floppy disk, later it became small metal pieces which we called as a pen drive. And later on in the late 90s, The pen drive was slowly replaced by even hard disk when the information was very high. And many of the information which we looked for were not in bound registers, were in the form of material stored in the internet. But now the generation of our students is quite very interesting. Everybody is singing. There is too much amount of singing, too much amount of music. I don't know who sings where and who sings what. Nobody understands the music. This is exactly what is happening to even the data that we handle. Most of the data is not now on the desktops. It is somewhere in the cloud. For example, the letter I write, I put it into a Google Drive. I don't know whether I can point out if somebody asks me, where is your letter? I can't show my laptop because it is not in the laptop. It is somewhere in a server which can be in the US or in Korea or in China or in Dubai or in Germany. I don't know where. So I have created a letter which is lying somewhere in this world in some electronic form. So similarly, the students are talking not to one, but to many in one go. If I am given the opportunity, or which I would refuse to, if I want to peek into the mobile phone of any of my younger generations, maybe a son or my student, I would refuse to, because I would get confused, or I sometimes became insane, because they would be communicating with 10, 15 or 50 or 20, 60 people at one go. They're not talking to one person at a time. They are communicating with a lot of people at a time. So what happens? Their communications has become so wide and large that I think the way they communicate has also changed. Their spellings have changed. The way they use data has changed. And whatever data that they try to accrue for themselves is all in some electronic format. And what happens is, every time they get to make a communication or hear a communication or take a communication, all this goes through the electronic format. So what happens, these electronic data equipment like the mobile phone or the laptop or whatever, these devices have some kind of a footprint that is left off by the data, and these footprints also become data by themselves. So what happens, it's a mind-boggling large cloud of data which is lying around in campuses, in homes, in offices. The entire world is swamped by one word, which is called as data. Similarly, in campuses, you have learning, and that learning is happening everywhere in the form of listening, talking, writing, thinking, watching. You have computers, you have social platforms, you have mobile phones, you have ebooks, you have e-devices. So I think if you just put all these together into one mosaic, the entire environment is too complex to be handled in a simple method by which we were handling learning and teaching data over the early 80s and 90s, or even up to the late 90s. So what are the different data that we have in an educational environment or any office environment? We can classify them into structured data, unstructured data, and semi-structured data. So what we have recorded in Excel sheets, which are tabulated on data sheets or spreadsheets, or whatever we call it as, that can be taken as structured data. But there is a lot of other data that we have. If you can just, all of us, if you can open your desktops or laptops and you can see the drives, different drives and desktops, you'll find you have a folder. You open the folder, you have 5 letters, some 10 photographs, a few audio files, a couple of video files. So all these folders have become unstructured in character and can carry a repository of different material of different shapes and sizes and different objectives. See, that's where these, see, if you have a data sheet, the material that is inside the data sheet is accrued there for a single objective. But in an unstructured data, the data is accrued together for different objectives. So variation in objective of a collected material is quite very complex and sometimes very funny also. And if it is in between, then it becomes semi-structured in character. Sorry. Yeah. So what happens is, this data that we have is too many. So if you are forced to, if I ask any of my faculty, or if I ask any of my friends of why do you want all this data? They will not have a specific answer for that. But what happens is, what becomes specific is, the data you need. For example, I go to ask a teacher, how many of your students in pathology has performed well? He would try to look at the data pertaining to the pathology students. Or how many students are doing research? They will start looking at the data that is pertaining to research of undergraduates. So what happens? The needs of data, or why do we look at certain data, or why do you try to search for certain data, varies according to the need. And the need is always situation or problem driven. For example, I call up my anatomy professor and says, why are so many of your students absent today? So to answer that question, the professor requires certain data. So he or she will be looking for specific data concerning that. So the need of a data varies according to the learning, the learner, and the learning environment. If it is learning, it is in the form of concepts, content, delivery, and assessment. If it is about the learner, it is about the personality and ability of the student and the learning styles of the student. And this is sometimes very vague, but it is most of qualitative data. I think as I go down on the talk, we will be able to see more about that. And the learning environment is the classroom environment, the LMS environment, library, and social media environment. So now coming to medical education. So let us try to understand what is the different type of data that is usually generated in the medical education parlance. There I have put up 6 different points here. One is the learner, the faculty, the institution, the administration, the government, and the public. Let us divide them into the right 3 and the left 3. So in the left 3, as I see it, is the learner, faculty, and institution, and the right 3 are the administration, government, and public. These 2 sets of individuals have different take on medical education, different viewpoints about medical education, and different objectives about running medical education. For example, to be very plain and frank, all of these people are selfish by themselves. The learner is selfish in the terms of he wants to learn medicine, make a good living, earn some money, have a good family, have some good practice, and settle down in life. The faculty is already there to earn money. He wants to come in, do some good teaching, get some good name, make some papers, and do some research, and of course, make a living out of the profession. Institution, they want the learner and faculty to work hard so that the institution grows in fame and they set some standards or reach some standards. While it comes to the other round, the administration, government, and public, their viewpoints are slightly different. The administration wants good doctors who can serve in the public and make the administration proud, or maybe they can stand up to the politicians. The government, which I mean the political and the top executive, like the Medical Council of India, for them it is all about creating quality human resource, and the public is all about getting good health care for themselves, that their health and medical needs are looked after well. So these 3 people with these different aims are looking for different issues. For example, the learner looks at the learning objectives, the faculty looks at the teaching, the institution looks at curriculum implementation, the administration looks at the curriculum development, the government looks at educational policy, and the public looks at aspirations. So you need to look at it in the reverse. The public is the Lord which generates all the information required for this entire continuum. The public has some kind of a health or a medical demand, which is the aspiration of the public. Based on those aspirations, the government looks on the best way possibly to handle medical education. It produces what is called as a educational policy. This is exactly what is happening in the last 3-4 years, or maybe 5-10 years regarding medical education, where we have slightly changed the way we are going to look at teaching in the coming years, like what we have called as a CBME, whatever. When this policy goes down to the executive develops a curriculum, or it has a development plan, a plan by which the policy is implemented, and an implementation plan. But the institution has a different problem, because the curriculum is sent down and the institution has to implement the curriculum. And the curriculum is broken up into small teaching modules. The faculty has to implement the teaching modules, and the learner has to take up what his objective is and what's the teacher's objective is. He has to merge with the teacher to learn. So what happens? The public needs has driven educational policy. Educational policy has driven development. Development results in formation of strategies. strategies produces plans, plans produces lesson plans produces learning. The first three now fall into a category which is called as milestones, and the right three fall into what is called as timelines. So you have implementation or administrative timelines, and the data in teaching becomes what are called as the learning milestones. So when the milestones and timelines are adhered to, what happens? We need to do some kind of an assessment to find out whether all this implementation business is working properly. So what happens? We have formative assessment for the student. There is a feedback for the faculty. Again, the institution does a feedback. This feedback reaches the administration in the form of midterm reports. The midterm reports reaches the government in terms of midterm evaluation. And the outfall or the discussion of these evaluations reaches the public through the press, what they call as the feedback from the government. And finally, when the student reaches the final years, we start looking for certification of the student's capacities, which we call as competence. The faculty sits down to find out whether he has really delivered in the form of appraisals. The institution tends to review itself in terms of its improvement in teaching characteristics and teaching capacities. So it becomes a review. This report reaches the administration. There is a review report, and the review reports are all collected and goes to the government to form a policy evaluation. And then again, through the press and through the political heads, it reaches the public in terms of a feedback. And coming to what happens finally is, the student goes through a summative assessment. The faculty, through his appraisal, has created innovations. The institution, through its reviews, have created some kind of an educational research. The administration, through the review reports, has recalibrated its strategies. The government, through the evaluations, has taken up some more reforms in the way it looks at educational policy, and all this reaches the public again. And coming to the what you call as the learner gets a certification. The faculty gets a positive appraisal. The institution gets a good name in the society. The administration is happy about the social outcomes. The government is happy that its policy is working or a policy success is there. And the service public gets a socially good health system. When I explain this, this is usual stuff. Why do you talk all this in a data analytics environment? See, from what the learner objectives are set by the learner himself, the aspirations of the public sets everything in motion to the last thing where everything is achieved. A lot of information has flowed between all these 6 stakeholders of the health system who are controlling medical education, of which I will just to exemplify what exactly the amount of data that flows, I will confine myself to the teacher and the student. In the medical education environment, what happens? The data that flows between the student and teacher can be restricted to 3 eras. That is the pre-computer era, the internet era, and the high-speed computational era. The computational era, I will talk last. But when it comes to campus interaction in the pre-computer era, it was predominantly face-to-face. The teacher met the student met the teacher, they talked to each other. If you can remember, maybe 10 years ago, all of us remembered the faces of our students. And most of the students remembered the faces of the teachers. Probably they even shared a cup of tea. They were friendly. So what happens? The teacher understood the student better, that their personal issues could have been solved faster and better. Now, the interaction in the internet era has become E2E and mobile to mobile too. So a lot of digital communication has taken up. Classroom interactions, you have physical in the early era, now becomes physical and digital. Assessments, predominantly paper, now has become paper and e-tests. Feedback has also moved from paper to e-portals. Records, confidential reports have become emails and e-portals. The campus chatter, which was literally paper in the campus magazines, has become social media and campus websites. Alumni interactions or alumni impressions or alumni accolades were all in the press or in the campus magazines, now has become social medias. You see more about your campus seniors and alumni in the social media and the groups that each campus has in the form of WhatsApp or Telegram or Instagram or whatever. And public and press opinion, which was predominantly print newspaper, moved to televisions, and now it's mostly in the social media. But now with high-speed computing, all this data, that is the hard copy data and the e-data or mobile data or portal data, have been injected with what new thing called as data analytics. Data analytics is one statistical pipeline which has now found itself into mobiles, into e-platforms, into the massive online open courses platforms, the LMS. It has gone into the social media platforms like the Twitter and the Facebook. So what happens, whatever data initially was there was analyzed by the teacher or the learner themselves, and they found their solutions in the pre-computer era. In the internet era, the data was many, but what happened, the solutions were taken with some minimum data which they could analyze. And there was a lot of unanalyzed data that was lying around in most of the campuses and classrooms. But in the high-speed computer era, what happens? The analytical engines are picking up all those data which was thought to be initially as useless and is trying to analyze. For example, when you are taking a class and you found one of the students in the third bench was smiling at you, you would either take it as probably the student appreciates your class or he was doing something else funny. So you may react or may not react. That was the only reaction what you call as the usual classroom had. But now a videograph of the class would be stored, and after 100 classes or 200 classes, the videographs would all be checked. A data analytical engine would check all the videographs and pick up all the smiles or grins or sniggers, and will create some kind of a database which will give you a new meaning to what the class what happened in the class and what better the class could have been. So what happens, the data of learning now is between the learner, facilitator, institution, governance, and everybody is talking to everybody in form of different e-platforms. So from this picture here, I have placed to find out what is the web of communication that we are into without actually realizing the amount. So if you take as one communication is one data, even for the minimum, because one communication can never be one data, maybe at least 10 to 100 data points will be transferred by each communication. If all this is together, it is a rain of communication that is happening. And to be even make things even more compounded, all these data points are stored in electronic form or digital form in just this formula of 1011001. Since this data is lying in large resource networks all around the world, in all around campuses, in most campuses which have well-developed computer systems. And the data analytical pipelines are now taking up these stored data and making analysis, giving you a lot of statistical answers for what data is that is lying. So quantitative as well as qualitative data which is stored is being analyzed. So this issue is called as big data. When you have too much of data, which is too enormous for you to physically look at, but has some value if you can handle it, is big data. So big data is unstructured, exponential, large data, which has big in volumes, large in fast in velocity and furious sometimes. It has got a lot of variety, and if handled properly, has some value and can give you some kind of quality analytic data for you to look into the what you call as the outcomes of collecting this data. Now, I will be introducing you to a couple of terminologies. So data, I think most of you have heard of it, and you all are sometimes even better at handling all that than me. So data is a number or a nominal or some measurement. For here, the data integrity is a vital issue. For example, the attendance register lying on your table is a form of data, right? If you measure it, you need certain kinds of what you call as the parameters on which you can measure. So for example, if you say an attendance less than 60% is highly inconsistent, above 90% is highly consistent. So this classification is called as metrics. And when the metrics is applied, and you find that 10% of your secondary BBA students are highly inconsistent, that is analysis. That is very simplistic. You are just taking one batch of 150 or 250 students, you put your metrics in, the analysis says that 10% are less than 60%. So it is 10% are highly inconsistent. But if you add the videos of the classes, the qualitative feedback of the teachers, you ask the students for a feedback, then you have a couple of social media comments that happened during the process of the class. You find out how many of the students were active on their mobile phones during the class, how many of the students were messaging each other in WhatsApp when you were talking in the podium. All that gets into the data which you are looking at. The highly consistent student or the 10% which we are talking of has some other data which can add on to the reasons. So here what happens, you come to a conclusion that the highly inconsistent student in the first year comes from a rural background and the regional language medium class from which he studied. He has financial issues in the hostel, and the teacher who is teaching him is using a British type of English accent. This is the answer that comes out. Now, the issue is not about calling the student in and asking him why he is inconsistent, but here is calling in the teacher to change the accent, calling in the hostel to find out whether the, what you call as the scholarships have been given in time, possibly calling in the mentor and asking him to help the student with regional language support, and possibly counsel the student to not have a negative feeling or a inferiority complex. So what happens? The answer is too many for a single problem, which was in analysis, which looked like a simple problem of a few students who were inconsistent. But analytics has shown that the problem is elsewhere and the solutions are elsewhere. Now, I think you will understand that analytics gives you a different meaning, or it sets in form a critical thinking of what was originally observed to be a simple problem. So let us say make a basic understanding of analysis and analytics. If analysis is reading between the lines, analytics is reading behind the lines. For example, if you analyze the MBBS second year results and say 98% passed with 10 distinctions, it is analysis. If you sit down to make an analysis of entire group of students who were there for the last 4 years, and then you say of this, some 5% will go for surgical training, 2% will go for medicine training, or that is predictive in character. Analysis is just making a conclusion about existing data. So till now, with whatever data that we had in learning, we were making only analysis, and analysis contributed to our understanding of learning was there, but to convert this understanding into effective interventions was sometimes very vague, or it was difficult sometimes. But analytics could help us in reorganizing our work and could help us in decision making and problem solving. So let us get to the major part of our talk today, that is, what is learning analytics? Learning analytics is measurement, collection, analysis, reporting of data from about learners, their context, the purpose of understanding and optimizing learning and environments when it occurs, or how, and actually real time where it occurs. So learning analytics is a complex way of looking at data, not looking at, or what you call as finding out measurement of the data. Learning analytics is a fast or rapidly emerging discipline, especially in the West, especially in larger universities in the West. But as of India is concerned, few institutes have introduced that, but we don't have any working examples of learning analytics or a big time learning analytics in this country as of today. And learning analytics is all about convergence of learning, data science, and user-centered designs. At this point, I like to underline one another word which sometimes may confuse you. What is academic analytics? In the earlier picture, I had shown you 6 stakeholders. The 3 stakeholders to the left side were the learner, teacher, and the institution. These 3 people, if they coordinate to improve learning, it is learning analytics. While the administration, the government, and the public, if they try to do something or do data analysis to help learning, that is academic analytics, where the analytic engines will be predominantly in forms of business intelligence applications. So they don't use the usual kind of stuff which the learning analytics use. Academic analytics is slightly different, which is based upon the public or what you call as social goals. Now, how do you apply analytics to learning? So you have some kind of a hierarchy with something is very similar to what we do in education. So here the baseline is collection of data, then you organize, clean, and prepare the data. Then you put analytical engines like some kind of a regression analysis or regression pipelines. And the output of the pipelines you use to predict and then test it. That prediction level algorithms are prepared. And once the machine learning algorithm is prepared, you can put it for deep learning. And further, if it becomes the deep learning is so capable of producing some kind of intelligent self-response, then it becomes artificial intelligence. The basic mathematical or statistical workforce that we use for learning analytics in learning are predominantly these four. That is linear modeling, where you do an analysis of continuous response variables, or the ITM response theory, where it's predominantly about assessment, the MCQ questionnaires, the what you call as feedback questionnaires, post and pre-analytical questionnaires, all that. So questionnaires and ability and attitude tests fall into this frame, where an item response theory is used to analyze. Classical test theory is all about qualitative data about a person. For example, you look at what happened to a class. Earlier I explained what happened to a class of students, because some of the students were giggling, some of the students were very morose, some were grinning, some were smirking. So there is different response of different students in the class for a same class taken by a teacher. The teacher's class is a unitary data. He doesn't take one sort of class for one student and one sort of class for another student. But 150 students react differently in sometimes 150 different ways for a single class. So what happens is, if the teacher wants to find out what is the best way to take a class or best way to make the student understand, he needs to do a psychological testing for all the 150 students and put that into one single data analytical engine and analyze. So for that, we need some kind of a method which is called as a classical test theory, where you have a lot of qualitative, and just only a small example, a lot of qualitative data can be examined together. Then you have the regression analysis, or the what you call as the curve fitting linears. These are all again higher order mathematical applications in learning analytics. With all these engines, you can classify learning analytics into four types: the descriptive analytics, diagnostic analytics, predictive, and prescriptive. I will become very, very simple at this point. Descriptive analytics. Descriptive analytics is, if you go back into your registers, you have 10 feedback registers with for 10 batches. Then you have attendance registers for 10 batches. You have classroom test marks for 10 batches. And you have data about their extracurricular or co-curricular activities for 10 batches. If you take all that data for the last 10 years, then make an analysis and find out how exactly the students came in, how they progressed in front of you as teachers, and how they graduated, and how they are performing now. So descriptive analysis or analytics gives you an insight of the past, which can be applied to the present and the future. So it is simple existing data analytics, which can be qualitative as well as quantitative in character. As simple as that, which at present we are doing it. But most of the data which we handle today is quantitative in character. But when you want qualitative, you require what is called as data mining. If it is all this data is in electronic sources. And then, of course, to integrate qualitative and quantitative data together, you need pipelines which are analytical, or analytical engines are required. Now coming to diagnostic. For example, I asked one of my teachers, why is the third MBBS student not performing well? If you want me to answer that question, we need 3 or 4 issues. One is, I need key performance indicators. What are the key performance indicators for a student? His formative assessment, class test marks, his attendance, his probably answering in the class, certain indicators which teachers always have. Then these indicators are put through certain kinds of designed metrics, where we say these are high performing students, these are low performing students. So we classify the indicators and you try to put them into different brackets of analysis. Then you go into these brackets of analysis and find out what exactly is this data, or what is happening to the data. And at the end of it, you come to say that this pocket of student has this problem, so he didn't perform well. This pocket of student is having this positive thing, so he is performed. So what happens? Even then, the data will not tell you that this is the reason, but what will happen is, you have certain positive indicators, certain negative indicators, and certain gray indicators. So the evidence is now weighed against the value or the intensity of the indicators, and say, if, for example, if the best students are all wearing white shirts, your data analytics will show that those who wear white shirts will perform well in your exams. If you have students wearing spectacles are all doing very well in their examples, your data mining and your data analytics will say those children with spectacles will perform well. So what happens? The spectacles becomes a key indicator. White shirts become a key indicator. Uncombed hair becomes a negative indicator. A shirt with the front button off would be a negative indicator. So what happens? These are measures which the videograph of the classroom, or a video CCTV camera recording of the lobbies, or your records or your feedbacks or whatever confidential report the teachers has written, all these will show up small interesting non-specific data which are pulled together. Because of the number of data that you have, all these become very prominent and will start telling you some information of how to handle a situation. So this is diagnostic analytics. Now coming to predictive analytics. You have a set of data that comes into your office moment your batch comes in. For example, if you're an anatomy professor, you collect a questionnaire form or something, what you call as a biodata from your students. Then you have the +2 marks, your NEET marks, the photograph of the student. Then you stand in front of the auditorium when the first batch comes in and you observe all the parents and students and teachers. And I think most of the senior teachers would all smile. We generally have a discussion on seeing the students and parents coming in on the first day of the on the open day of this college. We generally make some kind of an analysis with our own mind rather than not using analytical search engines. We say these students look like this, these students look like this. So automatically we are memorizing the pictures of the students and teachers coming, students and parents coming in, and we are making some kind of an analysis with our own physical brain. And if all this data could be lined up, and based on the data, you compare it with what was the outcome for such data over the last 10 years, 15 years. And finally, you just show a photograph or a videograph of an upcoming batch, the data analytical engine will start looking at and saying the boy standing in the second left of the photograph will become a surgeon. The boy standing in the third left or the third right of the photograph will probably become a logician. If it can start predicting, because there are lots of data sets the analytical engine has already seen, and by seeing this, it can tell you something, or possibly tell the teacher that this fellow, you handle him very cleverly, this fellow is going to sit in the last bench and create problems to your classes. You will start watching that student, keep him in the first bench so that you can manage your classes better and manage his learning better. So automatically, historical data with identified patterns, if it can help you in predicting the future learning process of your existing students, it becomes predictive analysis. Now, prescriptive analysis. Prescriptive analysis and predictive analysis are sometimes very closely linked, because what you predict, you try to repair with the existing data, that is prescriptive. For example, if you say, if I move 5 students from the last bench to the first bench, of the 5 students, 4 students improve in their learning. This is your analysis. Then what happens? You move the 5 students to the front bench. At the end of the year, if you see that all the 4 or 5 of them have improved in their classes, then this data goes in accrues over the years. And every time you have a bad set of people sitting in the last bench, you get an alert in your mobile from your own analytical engines in your institute saying, these fellows are sitting in the first bench. When you go to the class next time, you move them to the first bench. So automatically you do it. That prescription has been given to you by the analytics engine. You are doing it. And if those 5 students start reading well, it is learning that has been improved by the prescriptive analytics. Now let us see, how is it that we are going to apply this to curricular activity? So curricular activity has a lot of information that we have, lot of what you call timelines we have, right from what you call as the student writes the NEET exam and sits for class 12, has an admission and induction procedure, then starts doing classroom interactions, he makes e-portfolios, makes formative or attends to formative assessments, uses the library, goes online to study, gives you feedback about his learning, then you do some competency certification according to the MCI, and finally he sits for his final year exams and gets into the CRR and leaves the system. So that is a summative assessment. So this process has a lot of data which is generated. And these generated data lies in most of the institutions. And I think most of the senior teachers will agree, when the admission comes in, we have a data collected about the personal information of the student, the marks gained in the +2 and the NEET, and then about the financial status of the patient, sometimes of the student. Then we do collect a lot of personal data in terms of co-curricular and extracurricular activities the student has done. In the classroom interaction, we have videographs, especially now that the MCA has made a videographing of classrooms very as compulsory. So what happens, there is a 24-hour, 24/7 collection of videographs of running classrooms. Students collect e-portfolios, which they can keep in databases, which are part of the learning management systems of most modern colleges. Then you have the formative marks and the feedbacks, the library, the time when the student goes in, the number of books he is seeing, or what type of books he is seeing, how much is the time he spends on each book or in each library area, the websites he visits, and what is the time he spends on each website, what is the clicking rate, or what are the clickers, and sometimes what is the Google message which diverts him from educational areas to non-educational areas, what are the types of non-educational areas he's using while he's going online. Then of course, what are the interactions he has with his fellow students and teachers online as well as offline. And then about the number of certificates he receives and number of attempts he takes to receive the certificate. For example, you have a competency certification for CPR, doing CPR. Does it do in one go in the first attempt itself, or he has to undertake 3 corrections, 4 corrections before he gets the certification? And what are the levels of marks he gets in each of the summative assessments all through the 4.5 or 5 years? And what is the final CRRI report that we have? So all this data is there in your LMS or in your learning management systems, which we have in your colleges. If we try to analyze them, we have a lot of interesting information that we get. Here is a graph of the COVID active cases in my place in Tirunelveli, which is 70 kilometers north of Kanyakumari. This is a graph which shows how from 21st of March, we started getting coronavirus patients to our hospital. And slowly the numbers rose. And by possibly, I think 21st of March, before we got the first case, on 22nd, I think we had the first lockdown announced. The students left the campus. So my analytics in the Google Analytics of my college, intranet, gives me a very interesting story. If you can memorize this map over this graph, and I move to the analytics graph of my TVMC online classes. We have an online network of Google Classrooms as well as Google Meet, which we have been running for the last 1.5 to 2 years, even prior to what before COVID came in. When the lockdown was announced, we had only almost 50 students who were regular with the online classes. But when the lockdown progressed, the first MBBS students joined in, second MBBS came in, the final and third MBBS came in. So now, as of now, we have around 750 MBBS students in our Google Meet network. So this graph is an analytical, data analytics, the data which I have, which will tell me for every class how many students are attending, when are they attending most, when are they attending less, which class they attended most, which class they didn't attend at all. For example, in this part of the graph, you will say, see, there has been either this could indicate that there was no class on that particular time, or possibly the class was not attended, or possibly there was a less attended class here, like here. So these indicators will help me to talk to the teachers to find out where exactly the problem was, or what exactly the children wanted, and what could have been better to make all the children to attend. So here, this line indicates what is the 30-day consistent student attendance. The 13-day consistent student attendance was almost 750. So almost all of my students are attending to most of the final year, second year, and third year classes. Here, what happened after lockdown to my college website, college LMS drive? See, the data usage has suddenly started going up. That means my teachers and students have started uploading a lot of educational material since March 30th. So that could be in the form of PowerPoints, data sheets, or documents which they are trying to share with each other. So what happens? This is a very good indicator that my teachers are doing a good amount of teaching online and my students are responding very well to whatever online teaching that is happening. Now coming to the Google Chat. This Google Chat analytics here shows that since March 30th, there is an exponential growth in the chat box work in the different classrooms of the different batches. So automatically this means that my students are interacting quite very well to my teachers. That means the Google classrooms are quite very interesting and is creating good results. So this indicates that the students are interacting well, teachers are interacting well, and the possibly then we'll have to look for outcomes. Once the students come back from the lockdown and when they enter class, the assessments, if they possibly start, then the end result of this interaction would be clear with the assessments. This is an example which I have taken out of an Entrada group. This is about the LMS application in library, where the number of visits in different times of the year, different times of the months of the year can be looked into. What are the pages visited online? What are the books searched for online? So library use analytics is a very interesting thing which most modern institutions would be interested in applying, because that will give you a very broad view of what is the what you call self-directed learning capacity or self-directed capacity effort of your students. So that could be in the form of online clicks, navigations, where do they navigate, what are the assumptions that they are putting into the Google typeset to find out their information, what are the interpretations they do for the assumptions, the return on assumptions. If there has been any confusions and they go to a wrong page or a wrong information, what was the assumption and what was the interpretation, what are the different pages visited, time spent on each, and then automatically, I think most of you, if you remember, whenever you use Google for 5-6 times, and then the 7th time you go in and just type A, it will give you some 10 or 15 alternatives of the words beginning with A, which you have earlier used in the last 1 month or 2 months. So the Google is analyzing the way you type. So there are a lot of predictors that are available in what you call as a customized Google platforms. For example, the Google education platforms, which we use in our institute. So if you go and if my students are using the Google platform using their college email ID, the Gmail ID which we give in the college, if they use that as the what you call a sign-in default, then my predictors or the Google analytical predictors will be looking at how much of these teaching pages or learning pages they visit, non-learning pages they visit. All these analytics get recorded in our analytical systems. And then the last thing is the social networking. This is the commonplace for our youngsters that are our students. Teachers may not be using many of the social networks that the children use, but the rapidity which they use, the variety they use, what happens, these can sometimes help them and sometimes be inhibitory to their learning process also. So social networking analytics is going to be a very important weapon or a instrument or intervention in campuses to make learning better in the coming years. But this again involves a lot of other ethical issues which I would be pointing to in the later part of my talk. So utility of learning environment, learning analytics is, it helps in creating trends, it helps in modeling, personalize and create adaptive systems for our students. That is, it can improve the decision making based on the actual data. It can help in the institution's reaction to learning, increase productivity of learning, and of course, finally, it can improve student performance and by personalizing instructions. For example, there is one student who is lagging behind. You find that the student has spent too much time on his what you call as a Telegram or Instagram or whatever you call it. Then you possibly take him through a counseling. You make him avoid or reduce or change the way he looks into all these smartphone, what you call as social media networks. So what happens? This guidance can be provided by a campus and personalize what you call as the way we look at students. And of course, possibly if sometimes we can help them in looking at a particular part of the studies closely or look at a particular part of the studies differently. then possibly the student performance will improve. So adaptive learning would be very much possible if we have data analytics of learning happening in campuses. Let us go through a couple of examples before we close down. So you have learning analytics as a method to improve quality of multiple choice questions. This is a very interesting publication. I think many of you would have already read this. I would advise to go through this publication. It's very interesting to find out a classical test theory and item response theory being applied to multiple choice questions. An analytical search engine looks into the different MCQs and finds out how many are very tough, how many are easy, which MCQ is important for that particular topic based upon the objectives of the topic or the specific learning objective of the topic. So automatically, the way you set your MCQs, way you assess MCQs varies. Now, presently, what we do is we do the blueprinting. We have an MCQ set. We have marks for it. So somebody scores 100, somebody scores 10. So that score is good, that score is bad, that score is average. This is how we go about analysis of multiple MCQs. But here, for every multiple choice question, there is an analytical discussion. That is, if the student doesn't answer this MCQ or goes parallelly, or goes blatantly wrong, then that means this student has a lacunae in this particular area. So all this analysis can be presented to the student so that after a couple of these formative assessment tests, he can go back to his room, read the text, read the books, read the necessary, take the necessary knowledge or take the necessary guidance from the mentors so that he can change the way he reads and learning automatically improves in quality. Analytics for action evaluation framework. This is an interesting thing that happened in a science university in the University of, in the United Kingdom Open University, where they put in learning analytic metrics for students to respond when they study. That is, in all the teaching modules, they put in analytical frameworks. So these analytics were just only capturing the response of the students during the process. So what happened? Based on this, they created certain what you call as the assessments of the design of the modules, the process in which the module was implemented, and the outcome of the module. So this helped the UK Open University to reframe the modules for the psychology and arts modules. And so what happened is it became more of student friendly. The modules became student friendly. For example, I will ask you a very simple question. Now, as the CBME is being implemented, we are having a lot of modules, foundation course module, then you have the ECE module, you have module for AdCom, you have module for electives. So all these modules are there, which have been prepared by the MCQs and given to us in different points of time. But how many of us, if I ask you a question, how many of these modules will work well with our students? If I ask you, I think many of us will draw a blank because we have not had a feedback from the students, and the students will be giving a feedback all these years when in maybe in another 3 years, 2 years or 4 years down the line, all these modules, when they are being implemented, students will bound to give us feedback. How are we going to record those feedbacks and respond to those feedbacks through our analysis? That is one question which is left unanswered. That becomes a part of our digital response, or analytical response to teaching. See, basically we need to collect those data, and the data could be varied. We need learning analytical engines to assess and redesign the modules as and when we implement. Coming to the case, the study 3, learning analytics improves online formative quiz engagements. This is quite evident from the way my own faculty here in different departments are handling quiz programs in the last 5 years of COVID, last 5 months of COVID. The different sorts of what you call as online formats are used. The online responses are quite very varied. Some used Kahoot, some used Google Forms. A lot of different methods have been used. So what happens, the learning analytic engines, if we go through the data, I think I have not still gone to that part of the data. If we look into the analytic data of such different kinds of search and what you call as the e-modules that are used, the format of the quiz can be changed or can be improved to improve quality. So learning analytics improves the way in which we do online formative assessment as well as teaching also. So utility of LA can be threefold: one on student progress, the other on student behavior, and third on student learning. So I'll come to student progress. I'll give you one question. What is the reason why there is a increase in admission to certificate time for 25% of MBBS students in a particular medical. Just an example. It's a very hypothetical example. If I ask you this question, why some students stay inside the institution for 7 years, 8 years and do not pass? For this question, we don't have a single answer. So we require certain data which are qualitative and quantitative, what we call as the course grained data. Quantitative means exam marks, IA, attendance, all that. Qualitative data means classroom interactions, campus interactions, feedback data, LMS data, registers. If you put all this data together with the earlier data of how the student came in, high school performance, NEET scores, etc., this data together, if it can help in creating an environment where the student can improve the way he looks at studies, so that the performance of the student is improved and the admission to certificate time is that is the what you call as the loss of certificate time is reduced. And if we can come to a 0% level where there is a higher admission certificate time, that helps learning. So the progress of the student can be well monitored using analytics. So this classical example of an open academic analytic initiative, this was in the University of New York. I think this publication is out there in the internet. You can look it up, where search engines, analytical search engines have helped in looking at how the first year GPA and the classroom performance gave indicators to the teachers in the higher order departments. This was developed in the Purdue University also. So this database analytics helped in teachers advising the students and designing the curriculum so that students did not leave the course midway or break the course midway or stayed back in their courses for a longer time. So this ensures two things. One is the student is happy about his performance, teacher is satisfied about his performance. Third thing is, as a society, we get doctors on time. So the number of doctors which we aim at by using different medical college seats, we get the maximum number of students every year out there to practice and help us in the health system. Now coming to student behavior. If I ask you a question, why did 12% of the MBBS students in the men's hostel of GMCB lack performance? So I think many of us would have had this problem when we were senior teachers, where a group of students who are hostlers were not performing well. There were specific reasons. There were reasons which were not very clear also. So what happens again, we look for course grained data like the exam marks, IEA, attendance. This is analyzed. The warden's confidential report is taken. A feedback data from the formative assessment is taken. CCTV footage of the hostels, CCTV footage of the classrooms, of the lobbies. Security logs of the hostels are taken. Social media interactions of the students. LMS data of the student. Registers and security records. So you have so much amount of data types which we can look at. The analytical engines will now start identifying high risk behavior. Then once identified, are we going to take disciplinary action against the students? No. Actually, disciplinary action against students is a very regressive behavior that our educational campuses have these days, because the data that we are analyzing, we are doing only analysis. So we don't have any feedback of how to handle, but we have only a specific input saying, yes, this student has got a problem. So we are bound to respond to a problem rather than bound to respond with a proper solution. Analytics helps in that way that it gives us a solution. Here is a very interesting thing that Purdue University set in. In the LMS, they created what were called as the signals. Every time the student came out of a class or went into a class, the student's LMS gave him what is called as a green, red, or a yellow light. For example, based on the student's behavior in the hostels, his social media interactions, his campus interactions, previous recordings of the classrooms, his previous records as per as the what you call as the departments are concerned, all these were put together, and the student was given a feedback in the form of a traffic light, which had messages tailored by the instructors, and this feedback instruction also went to the instructors and teachers also. So when the student went into a class, he knew that this topic is slightly tough, you need to concentrate. This topic is easy, still you have not performed well. So he was red lighted, yellow lighted, or red lighted. So the student was made to push himself harder when he had red lighted. He was made to perform better. So this signal system actually helped in improving quality of students in Purdue University. And now presently for all the teachers, senior teachers who are watching this, this software is now available for use all around the world. Probably it requires a license by paying a small fees. Then coming to student learning. If I ask you, can you ensure student learning? My teachers will say, I can ensure teaching. I cannot ensure learning, because learning becomes an innate organic behavior of the student. I cannot control the brain of a student. So learning cannot be ensured. I can ensure only teaching. So if I try to ensure learning, I may not be able to do it on a usual course. I require analytics with a lot of fine-grained data, which will be quantitative and qualitative in characters, which I earlier said. And with the combination of psychometric data of the students, which can be either based on footage analysis or can be based on adaptive systems where the clinical mentoring and clinical psychology assessment of students can add to the data. Based on that, we can ensure that the students respond positively to the learning environment and they perform better. Maybe we may not be able to ensure 100% that the student learns. That is humanly not possible. But maybe a 25 to 30% improvement in the way the student learns will improve the quality of the student as well as the quality of teaching and the institution. So this has been tested worldwide in different universities. The United States, UCLA Crest, University of California, Los Angeles, they did what was called as a simulation-based assessment of ultrasound proficiency, which is a e-program where the way in which the what you call as the probe was picked up, the probe was placed, how the reading was done, all that was assessed using certain e-measurements. And based on that, the person was assessed whether he was really proficient with doing an ultrasound correctly. So this is again a software which is available on online for us to use and download. Maybe again it requires a license. So now coming to the strengths and weaknesses of learning analytics. You should understand that analytics creates some kind of an ownership of the learning process. It gives us so much amount of command. So the teacher as well as the learner becomes enthusiastic. That is a positive thing. And it helps us to imbibe a lot of skill sets. This skill sets improves for the teacher as well as the student also. There is a lot more of tools and algorithms, so they are all in the e-platform, so transparency improves. The data can be used in different departments. If one department does better, that can be crossed over to the next department. It can be cross-institutional also. And people can assess themselves by the multiple skill sets and the operating analytical engines. So it becomes more user-friendly, teacher-friendly, learner-friendly. So I think it has a lot of educational impact in terms of its usability. But weakness, that is one basic issue. You are culling into a large data of many of which are private or which belongs to the personal life of the student or personal life of the teacher. For example, you are looking at social media engagements of the student or the teacher, social media engagement between the student and the teacher, or in between the teachers and in between the students. So it hampers the word called as privacy, confidentiality. So what happens? How much of these data can be shared? How much of these data can be used? All these become questionable sometimes. So there are a lot of ethical issues in handling this data. Then the data is too large. They are too disparate. That is, they are different in shapes and sizes, as I told earlier. So there is a major problem of sharing and compatibility between systems. So what happens? My learning analytic software handles data differently. Somebody else has got a different program. Then automatically the problem is that his computer or his computer system may not take up my data. So crossing over of sharing of data may not be possible. And last thing is, you have so much amount of data in your server, and if your firewall and your security of your server is not correct, the data could be stolen. And hacking is a very common thing that happens these days. So much amount of data in a server sometimes is a big issue. So security of data is a major problem which we need to think about when we are looking at learning analytics. Then coming to the second part of it. I'm closing down very rapidly on this is because machine learning and artificial intelligence are the level next to learning analytics. When learning analytics becomes very dominant, then it moves into machine learning, and machine learning becomes dominant and self-reacting becomes artificial intelligence. So if something exists, but the brain can't learn it, it doesn't mean that it doesn't exist, but the brain doesn't understand. So similarly, you look at a data and you are not able to understand what the data is telling you. It doesn't mean that that data is not having any information, but your brain doesn't understand the data. So there, what happens, if you can just remember, uh, every time you have a mosquito biting you, you would be reading a very interesting book. Or sometimes you will be driving your car, your one hand slaps the mosquito and kills it. This activity of your hand is simply a set of coded instructions that is already recorded in your brain that has automated you to kill the mosquito the moment it bites. So similarly, your brain has learned over 1,000 years of human existence, thousands of years of human existence. Right from the days we were gatherer hunters, we have had a lot of experiences in life which we have gathered as small data pockets, and that data pockets are all stored in your brain in the form of your own genetic data. You should understand, all the learning data goes into your genes, and the genes are transmitted to your children. Children transmit it to the grandchildren. So automatically, you have a lot of data that your brain has. The brain has recorded it into the genes. The genes have been transmitted. So you have so much amount of data. And that's exactly why sometimes all of you would always remember, you go to a place which you have never visited in your life, but you feel that you have visited that earlier. Or you would try to see if a person and you feel that you have met him earlier. It is not something ethereal or something like extrasensory perception, what people call or make films about. It is because you have a lot of data in your brain regarding the face of a person, of a place, of the different things. So sometimes what happens, if the picture matches what data you have, it tells you that you have already met or you have. So your brain is already trained with a lot of algorithms. So the best machine learning, what you call as hardware, is your own brain, and the usual human social construct, the most sophisticated AI ML machine. And if you are trying to mimic that on a computer or on a server or on a large computerized system, that is artificial intelligence. If the machine tries to go through all the data, for example, I give you a very funny scenario. Then when I was typing this, I was smiling to myself. A professor started walking to the undergraduate classroom for probably a pathology classroom, whatever. A smart board system on the lecture hall starts lighting up, and the first slide for the professor's talk appears on the screen. The student's mobile gets an alert with a pre-test link to answer before the class starts. The professor's mobile shows that of the 40 students, 38 have already come inside and 2 are on sick leave in their hostels. The learning management system starts recording the class, that is the video machine start on, and a post-assessment file is now moved to the dispatch area of the system. Student A gets a signal light saying that he was absent for the last class, and this class is a continuation. So he gets a summary of the last class on the lab on his mobile screen and asks him to read it and be prepared, because the professor is going to start the class and he needs to understand that. And student B gets an alert where the LMS says that she has already read this in the library last day. So the professor would want student B to come onto the podium and summarize at the end. Without actually the professor doing anything about his class, if he walks and does, and the system does everything like this, this scenario is possible with machine learning and artificial intelligence, because the system is pushing the analytical engines to analyze all the data rapidly. And once the analysis is through, automatically it sets up certain responses, which could be actually taught responses or learned responses. So machine learning or the LMS systems with machine learning administers data sets, returns information deduced from the learned skills. So first is, you get so much amount of data, you feed it to the LMS machine. or the machine learning software, which is either R programming or SAS. A lot of programs are there based on Python or whatever. When you put the system through, you have a lot of different algorithm systems. These analyzes the data, and the data is put up on a spreadsheet. For every, there are some, maybe that data you are feeding has got 100 or 1000 variables. For every item, there is information about 1000 variables for every item. So for every new item added, the system asks you a question, what does this mean? For example, you have a data set which is about poorly performing student. You put the data set, it spreads it into 1000 variables. At the end of it, it queries you. And in the query area, you say that this is about a student who gets 25% marks in the pathology exam for necrosis. It learns. The machine learning system now memorizes it and says, if this is the data, this fellow will get 25 marks in the necrosis test. Next time, what happened? This is the learning phase. You keep adding data like this. Maybe for 1000 data sets, 5000 data sets, the machine now learns. Then what you do is you give the data set, the machine gives you an answer saying this fellow scored 20 marks in the last necrosis exam. You go back to the records and find out what was the real mark. If that fellow had scored 80 marks, now you tell the machine, no. For this data set, he has scored 80 marks. It now learns from the new data set. So it calibrates the different values in the different values of the different variables. And finally, maybe during the process of testing, this area is called as testing. So first was the phase of learning. Second is the phase of testing, where you ask the machine to make conclusions, and then you say what is the right answer. And then comes validation, where you put the data set and find out how much of the lab values are correct and how many values are wrong. And based on that, you make certain calibrated corrections. But at the end of the three phases of learning, testing, and validation, the machine learning machine will be making almost 95 to 97% of its predictions correct. So you give a data set, it will tell you whether the student is going to perform well or not, or the student has a weakness. And if the student can use this kind of software before he goes into a class, or he goes through the class, or he is just sitting for his exams, he will be able to make corrections in the way he learns. So learning is bound to improve. So this uses behavioral analysis, then about all the assessment data. So a lot of data can be put to use when you go through such a kind of technology. So machine learning helps in adjusting course delivery. It gets rid of administrative busy work. It does a little amount of smart automation also. It personalizes content delivery for the learner and helps the teacher on what to deliver, and responds well to the learner's questions and gives him intelligent feedback. Such kind of machines are few in number all around the world. Few of the universities are already doing a lot of research. The University of Singapore is in a very advanced stage of preparing such kind of things for science universities. So with all this, now we have a question in mind. That mean that the computers are going to replace the teachers and replace the educational or learning administrators? The question is a big no. It will enter ME in a big way, but will not replace the teacher. Will open big opportunities, but will not replace basic concept delivery, which the teachers are adapting and are dominating for thousands of years. It will assist teaching and learning, but will not replace. With this, I would like to thank my team of team in the medical education unit and the curriculum implementation committee at Tirunelveli Medical College, especially Dr. Swaminathan, Dr. Anandi, Dr. Vasiji, Dr. Sunitha, Dr. Pavita, Dr. Nirmala, Dr. Sendil Kanita, Dr. Tenmuri, and Dr. El Ramya. And I have a great word of thanks to my dean, Dr. Ravichandran, who has been a great word of support. And finally, I thank Dr. Jayaprakash Rajan of the JIPMER Medical Education Department, who has been a person who has encouraged me to indulge in all this. And today's talk was a result of his encouragement and opportunity. Thank you, Jayaprakash Rajan, and thank you all for being quite very patient. I think it was a long lecture of almost 1.5, almost near to 1.5 hours. Thank you for giving me a patient hearing. Thank you so much.
Thank you, Professor. That was a wonderful presentation. I can say it was very resourceful and scholarly presentation. You started very well by saying that all of us, all educators, we are surrounded by a lot of data. And you also mentioned that we should be able to identify or generate data from our day-to-day activities and how this data can help us in decision making. And you also cited, you also explained the term data metrics, analysis, and analytics by giving suitable case scenarios, case scenarios, and all your explanation were with suitable examples. That was a wonderful presentation, sir. I think now our teachers should be ready to take up these new roles. I think otherwise we will be left behind. I think because we are going to handle the new generation student, that is the millennial children who are already well informed than our teachers. And now I think all our medical educators have to should be ready to take up this new role of identifying, collecting the data, analyzing it, and applying the principles of analytics so that they can make effective decision while planning their education. I mean, for they can effectively take educational decisions. So thank you, sir. I now invite the participants to ask questions, post their questions. If there is any question in the chat box, I mean, if they have any question, they can post their question in the chat box. Or if they are willing to ask oral questions also, they are welcome.
Hello, sir.
Yes.
Am I audible?
Yeah.
I want to know how you this complicated
Please
data
identify yourself,
you
sir.
collected. Myself, Dr. Satish Dipankar, Associate Professor of Physiology, AIMS Patna. I am also very well connected with Dr. Jay Prakash Rajan sir. Since the NTTC, I completed my course and other things. Sir, I want to know how this all this complicated data you collected. This is a very much complicated thing. How this students' behavior and everything. How you collected this data?
See, these data is already available in most medical colleges. Only most of them are in hard copy form. See, you would remember if a student walks into a room with a problem, basically with a problem of his studies, the moment you make him comfortable, make him sit, you start talking. He gives you a lot of interesting information of what happened in his early life, what is the financial or mental problem he has in hostels. So these are data which is already there physically. So if you can make them as records in terms of, you can write it down, or possibly if you have an LMS, you put it into the LMS. See what happens when it goes into the LMS, the what was multiple pages of written material becomes data. So when it is lying in your feedback register or in your feedback notebook or whatever you carry, that is useful only to you. And basically when you try to analyze, you see when you do qualitative analysis, I think if you remember, if you do qualitative analysis, there is one thing is, first is a transcription, translation, and then you find out the keywords, you arrange the keywords, and then you go for an analysis. So this work, which is generally done manually, is very laborious. And if you have to do it for 250 students per batch per year, it's very laborious, so teachers won't do it. But if the machine does it for you, that is qualitative analysis, finding out the keywords, all that, if the machine does, it becomes easier. That's exactly where the learning analytics helps. Then coming to quantitative data, we are already doing it. See, nothing new about this system. Finding out the number of students who have got distinctions, number of students who are less than 50 marks, who are below average, who are average, all this analysis you're already doing, and maybe we call the students into our offices and advise them. So our problem is about qualitative data. We do not analyze qualitative data as teachers. This learning analytics systems collects the analytical data. There are a lot of softwares which, for example, if you have written material, there are certain search engines can identify keywords. If it is an audio, it immediately converts them into written material, shows it to you. You can make corrections. That is transcription corrections you can make. It becomes written material. Then keywords are searched for. So there are everything has got learning analytical or data analytical search engines all over the world. They are freely available in the net, and it's easily downloadable. Only one thing, we need to know computer science technology or data analytic technology, and as doctors we are poor in it. Either to know it also we don't have, because our teaching does not teach us about computers and computer usage. So it's quite very new to us. That's the only problem with us. And about videographs and audio, sorry, what you call as photographs, we should understand that there is one thing called as a lot of face recognition softwares which are already available. And if you have gone used to the Facebook, the moment you upload a photograph, there will be a small circle which will appear on the face of all the people who are there in the photograph which you have just uploaded. And if some of the faces are already matching with the photograph it has, it will give you the name also sometimes. And for some people which it doesn't recognize, it will put a circle and put a question mark. And automatically it enthusiastically allows you to type in the name of the person. So automatically your entire photograph of 20 people will have their names. It doesn't mean that the name is known only to you. The analytical search engine has already recorded the photograph and the name, and somebody else 100 kilometers away or 1000 kilometers away is uploading a photograph with a similar face, it will show up the name there. This is how photo analytics use. Similar thing is about videos. So videos are just multiple photographs of different time frames per second. For us, it is moving, but for the analytical engine, it is photographs taken at maybe at a rate of something like 10 frames per second or 18 frames per second, according to the video graph which we are presenting. So every frame is analyzed the way it analyzes every photograph that we upload. So classical example of analytics is if you do Facebook, you look deeply into the Facebook, that is where photo analysis is done. Same thing happens to video analysis. If this is put into the videographs of your classrooms. The classroom is for 1 hour, for 40 minutes, it is repeatedly taking photographs of your class. So every student has a reaction for every time you do things. For example, you are very classical, very funny example. But one of my friends was saying, one of the students got out of a class and told his teacher, "Sir, I'm not able to see the board clearly." This very interesting thing is the teacher immediately asked the student to go and check his eyes with the ophthalmologist. But the problem is the teacher was always seen moving across the screen. So what happens? The student was not able to see the board, not because he has an eye problem, because the teacher had a bad habit of literally dancing in front of the board. If you have a videograph of the class, automatically you know what is the mistake, not because of the eyes problem of the student, but it's because of the movement, podium usage of the teacher. So these kinds of issues is what videographs help. And very interestingly, I think most of you would understand, you would have walked through the old classrooms of old medical colleges. There will be a lot of small carvings and writings in the tables of students. I think most of the senior teachers, if you go through the lecture halls, on the table surfaces, you would have seen students scratching their names or writing something. If you go and peer very carefully, there may be a lot of information which would be feedback to your own classes. So all these are classroom chatter. This is called as classroom chatter, the way they respond. If you find that your class has a lot of WhatsApp activity, that means the students are not involving themselves or they are feeling distracted. The distraction could be your teaching or distraction should be something else. So these are the multiple data that you have in a classroom, which is generally not used today. As of today, we don't use it in India.
Thank you, sir.
Any more questions, please? Hello?
There are some questions in the chat box, sir.
Yes, sir.
Can you see those questions, sir?
Yeah. Yeah, if big data analytics of multiple major hospitals handled or yeah. 1 minute, sir. Yeah, this screen is okay. Yeah. If data analysis of major hospitals handed over to AI, can such AI determine which doctor treats what? This is Dr. Ram Shankar of JIPMER. If big data analytics of multiple major hospitals is handed over to AI, can such AI determine which doctor treats what? I think this is the common doubt we have regarding machine learning and artificial intelligence. See, this machine learning or artificial intelligence is collecting data from amongst ourselves. So it will have the pitfalls of what we have ourselves. For example, if some of our friends asks you an idea of which doctor to see for a particular disease, I don't think we will always be correct, because the data with which we have made the decision varies according to what we know and where we are placed with, or what situation we are. Similarly, AI cannot fully handle allocation of patients to doctors, or what patient will go to which doctor. This can never fully happen with an AI, but only one thing, AI can help or assist in making decisions, or otherwise that is called as supervised machine learning. So you need a supervision of the what you call as the technology, and that supervised learning also has to go in back into the AI pipeline to make it successful. An individual or independent AI or independent ML can never replace human effort. Next question is Jansi Malai from Jipmer again. Neha Singh, how to involve students more for feedbacks, as mostly they are not open to the real opinion. Is it possible? Dr. Neha Singh, can you reframe the question for me? I'm not able to get it.
Dr. Neha, are you there?
How to involve the students more for feedbacks, as most they are not open to the real. I'm not able to get the
Actually,
real,
I think if I am right, sir, I think she is asking about the feedback. Hello. Suppose nowadays, if we give feedback, students don't answer the feedback honestly.
Yes, see, very interestingly, this is what learning analytics is going to really help us. See, when I call in a student who is bad, who is not performing well, I make them sit across the table and I ask them a few questions. I ask them what are they doing. They may not be really telling you the truth of their real problems which they are facing in their hostel or in their room or in their homes, or they may not be really representing the problem that they are learning, their problem they are facing in learning. But what happens is, if you have a videograph of the entire interview, and if you have a psychometric pipeline that is attached in the learning analytics, the way they use their body language, their use of their eye contact, how they move their face, these are very specific information which can be used by the machine learning softwares to create certain information which can laterally be learned and supervised. So analytics can help you in going through such interviews, and probably the feedback processes can give you more information than what they are really giving you today. Yes, Rajashekar Chokalingam. Please, can you please name some good LMS systems and data analytical free software? I think a few of them are already mentioned as a part of my talk. I will do one thing. I will leave my email ID with Dr. Jayaprakash Rasan. You can have my email ID. You can mail me up. I will send you the links of whatever I have.
Okay. I think, sir, the presentation will be available in the YouTube, sir.
Okay, sir. Thank you so much, sir. Thank you, sir.
In a week's time, it will be available in the YouTube.
Yeah, thank you so much, sir.
And there is a question from Dr. A.U. Siddiq.
Yeah.
He's asking about, yes.
Keeping track of student activities all the time, does it pose mental burden to the students because they would know that they are being tracked? Dr. Siddiqui, I would like to answer this issue in two ways. Number one, today, even without knowing the word analytics, all of us, you, me, and everyone in our families, in school, college, everywhere, we are actually being tracked without actually, because the way when you get into Facebook or Twitter, you're already being tracked. Because when you are giving your permissions, there would have been a question that comes out from the particular social media, can you share location? So the moment you share location, your place is shared. When you can I look into your contacts? If you share it, your contacts are already there with the social media. So what happens? All of us are being tracked even today without getting into a learning analytics system. But here we are looking at an enterprise where whatever data we have in LMS with tracking or without tracking, which can be put to best use. But tracking can cause, that's what I said, tracking can be unethical sometimes. It can give you a lot of news about the privacy of the student or the teacher. So it can turn out to be unethical. So a proper ethical framework built around learning analytics and ML and AI in medical education is very important, because it involves a lot of innocent young boys and girls who come to universities in search of knowledge. So a clever computer science specialist who sits over these servers and data could sometimes become a very large menace for these children. So learning analytics requires a very strong administrative framework and a very clear guideline for its usage. Can I? Hello? Am I heard?
Yes, sir. You are audible.
Yeah.
Any more questions?
There somebody says even feedback can be influenced. So genuine response, how could it be obtained? See, I will tell you one thing. Feedback today, what the students tell you by voice is already influenced. It is influenced by his own opinions, his own decision of what to tell you and what not to tell you. So what you are hearing from your students is already influenced or colored feedback. There is no pure feedback that you get from your students. But if you can append it with the other the images of its what you call as of the interview, all that, it gives you additional data to understand whether it is colored, how much colored it is, and what type of coloring is it. Do you need to learn Python or other languages? See, I think basically if you are into learning machine learning and learning analytics, learning Python is essential. Python is a very beautiful small language. I don't think it takes more than a month to master it. You need to understand that it all starts from the base work of a Linux format. There are a lot of commands, and most of these commands are already there in open. So if you want a command, you don't have to break your brains to write it. You can search in the net, where you have a lot of databases which gives the command for which you are searching for. So understanding the basics of Python is very important. R programming is a very interesting and new thing. See, you should understand that R programming is far more powerful, and that is going to be the basis of most of the analytic search engines. It's already that. Maybe in future, when learning analytics comes to you, it will be all R programming. So understanding R programming is very important. There is a very interesting course on machine learning, which is run by Dr. Andrew from the University of Stanford. It is available in the Coursera. It is a 7 weeks course, which is called as the what you call as a toolbox for data scientist course. It is quite very easy, but only one thing: before you go into the course, you need to have some basic knowledge of Python and R programming. So all that is available in Coursera. You can easily learn it.
I think if there are no more further questions, we can conclude this session. Dear participants.
Yeah.
Okay, sir. Sir, once again, thank you very much, sir. It was an excellent presentation. I mean, I can say it was a scholarly presentation. You have covered all the, the basic fundamentals of learning analytics. I hope this webinar has provided useful ideas and a framework to think about the use of learning analytics in medical education for our teachers. And I think understanding learning analytics will help educators move beyond the traditional assessment towards making the learning process and learning outcomes more visible. So that is, I think, ultimate aim of learning analytics. You should always try to make meaningful interpretation and derive meaningful learning out of this learning analytics. So it is crucial that these changes be known in advance so that medical education can begin preparing medical teachers and students for these new roles. I think our teachers should embrace these new technologies so that they can make effective decisions in educational matters. So with this, I'm really grateful on behalf of JIPMER and on behalf of our NTTC team, Department of Medical Education. We thank you once again, sir, for your scholarly presentation and for accepting our invitation and for being with us for the last 2 hours. I think it's almost 2 hours, sir. Thank you, and I really appreciate the homework you have done, and the way you presented was very lucid and very fluent and with excellent information, with needful information. Thank you very much, sir.
Yes, thank you so much, sir. Thank you so much for your
all the participants
invitation.
for being with us, for traveling all along these 2 hours with us. So thank you, dear participants, and I thank on behalf of the participants also, I convey the gratefulness and thanks to our Professor Dr. Shantaram. Thank you very much, sir. We'll have looking forward for more collaboration from you also, sir. Thank you very much. Thank you, dear.
Thank you so much. Thank you. It was wonderful. It was wonderful.
Yes,
thank you so much, sir. Thank you.
So with your permission, I am signing out.
Yes, sir. Thank you, sir.
Thank you.
Thank you.